In this video, we are going to continue looking at the derivative of a natural logarithmic function. So on this particular type of problem, we are being asked to find absolute extrema on an interval from 1.2 to 4.2. So in order to do that, we need to first take a derivative of the given function. Notice that it is a quotient, so we're going to have to apply the quotient rule. So with the quotient rule, I take the derivative of the top, which will become a 33x squared, multiplied by the function on bottom. And then I have to subtract the derivative of the bottom. And so since that's where my natural log is, the derivative of natural log of x will be 1 over the function x times the derivative of the function x, which would be just 1, and then times the top, which would be 11x cubed, and then the whole thing is divided by the bottom function squared. Okay, so if I go ahead and simplify what I have there, I've got a 33x squared times the natural log of x, and then notice that when I get over here, the x on bottom here will cancel one of the x's on top, so that'll leave me with the 11x squared. So that'll be minus 11x squared. And then the whole thing is divided by the natural log of x squared. Okay, so if I go ahead and I set that derivative equal to 0 so that I can try to solve it. The only way a fraction is going to equal 0 is if the top is equal to 0. So my 33x squared times the natural log of x minus 11x squared, I'll set equal to 0. I'm going to factor, so notice both terms have a factor of 11x squared in common. And so when I factor that away from a 33x squared, that's going to give me a 3. And then I also have times the natural log of x. And then minus, when I factor it away from 11x squared, I'm just left with a factor of 1. So if I set the factor 11x squared equal to 0 and I solve it, if x squared is 0 and I square root both sides, there's one possible critical value, but notice it is not within my interval, so I will not even be considering it, because my interval down here is going to go from 1.2 to 4.2. Alright, so then if I take my other factor and I set it equal to 0, 3 times the natural log of x minus 1 equals 0. Add 1 to both sides, so 3 times the natural log of x is equal to 1. Divide both sides by 3. So I get the natural log of x is equal to a third. And at this point, to get x by itself, I'm going to have to change it to exponential form. So with a natural log, it's understood to have a base of e. So if my base is e, the 1/3 becomes the power, and we say that is equal to x. And we'll have to actually get on a calculator to figure out what that particular decimal would be. So on my calculator, I'm doing e to the power of 1/3, and that is going to be a decimal that is approximately 1.4, since they're only going to one decimal place, 1.4. Okay, so now I will test my endpoints, as well as I will test on both sides here. So I'm going to have to use a test point of 1.3 so that I'm in between 1.2 and 1.4, and then I could just use something as simple as 2 right here. So let's see what's going on with our actual first derivative. And so again, I would recommend you just get on a calculator. So you're taking these numbers, so the 1.3, and you're going to come back up here to this first derivative, and you're going to punch that into the first derivative, and then you're going to take the x equal 2, and you're going to do the same thing there. So I'm going to pause the video and punch those out real quick and tell you what kind of values I get. Okay, so when I plugged in my test points, I got a negative value when I plugged in the 1.3 here. So that says this graph is decreasing. And then when I plugged in x equal 2, I got a positive value, so it is increasing. So it's obvious that a minimum is going to occur at my x value of 1.4. So I just need to find the y value for that. And then my maximum can either be at the endpoint 1.2 or the endpoint 4.2. So we're going to actually have to plug both of those back into the original function in order to figure out their y value. So once again, I am going to pause the video, and I'm going to be taking the 1.4, plugging it into my original function to find my y value. Then I'm going to take the 1.2, plug it in to find the y value. And then I'm going to take the 4.2, plug it in to find the y value. Okay, so now that I plugged those in, when I plugged in the 1.4, my y value was 89.71. Down here, when I plugged in the 1.2, I had a y value of 104.26. When I plugged in 4.2, my y value was 567. So my absolute maximum is going to occur at the endpoint 4.2 because it had the larger y value, which was 567.89. Okay, so then on this question, it's just asking us to find the derivative. So once again, when you are taking the derivative of a natural log, you're going to take one, let's see, I'm going to have to get more room. Let me come down here. You're going to take 1 divided by this whole thing as is. So that would be a 10x squared plus a 17x in parentheses squared. And then it's multiplied by the derivative of this thing. So notice we have to first, we're going to do chain rule. We have to pull the power down, and then we have to do the inside as is, decrease the power by 1, but then we also have to multiply by the derivative of the inside. So that becomes a 20x plus a 17. Okay, so at this point, on top, we have 1 times 2 is 2. We have a 10x squared plus a 17x. And then we also have a 20x plus 17. On bottom, we have a 10x squared plus 17x, but that factor appears twice. So when I go to simplify, this factor on top will cancel with one of the factors on bottom, and then we're left with, on top, the 2 times the 20x would become a 40x, plus the 2 times the 17 would be 34, and then on bottom we get a 10x squared plus 17x, which you really don't necessarily have to have the parentheses there. So that would be my final answer for the derivative.